All right. If I had this here, and I had to find the antiderivative of this dude, turn, get up there, zoom. You can do it, Jeff. And I thought, oh, okay, it's just a natural law, because I don't listen to Jeff. Screw him, he talks too much. But how can I tell really quickly? There's no way. If I do like a surface level quick derivative, it would be 1 over stuff times derivative of stuff. That's not that. I made a mistake. Okay, I like it.
Would you factor it?
Huh? No, this would actually be arctangent.
Arc.
But with there's a bit of a, we'll do something like that later.
Yeah, that's gonna be on.
Do not assume that just because it's 1 over something, it's going to be ln. No, hell no, screw that shit. If I have, though, something that looks like this, then the antiderivative is going to be this, always and forever. Always and forever. Maybe. All right. Anything else from the quiz, or anything from homework stuff, or general stuff?
The A of the last one, right?
Oh, the.
F2.
I had to give you one of these. Something that looks sort of like. What can I do instead? Sure, Jeff. What if I had this?
That would be tangent.
The most important thing in there is secant squared. Where does secant squared come from? What would big ass G have to include in it?
Tangent.
Tangent, because the derivative of tangent would lead to secant squared, correct?
Negative.
So if you kind of put this down just to kind of feel things out, the inside of a function does not change when we do derivatives. Therefore, it does not change when I do int. By the way, I'm not done, am I?
We have 2.
That's not right yet.
So negative.
So there's a 10 here. If I take this guy's derivative, what's going to happen? I'm going to get secant squared stuff times
5x. Oh,
derivative of stuff, correct?
5.
So there must have been a 2 out here, so that when I do this derivative, the 5 times 2 gives me 10. You guys see that? When the inside is linear, I do not need u sub. I don't. Ain't no damn reason for it. Because then, all I'm going to be missing is a constant. The constant's all I got to kind of juggle, and constants do what we want them to. Okay. Functions done. They do whatever the hell they want. Is that okay? So I knew the answer had to have a tangent 5x in it. I knew it did. There's no other way around it. And then I just had to think, okay, how do I make the number work? It's like a second step to the problem. I know I got that right. I've got the heart of it right. I just need the dressing, the side dishes. All right, little side dish. Okay. Try to get my math course into culinary arts. All right. Anything else? Is that okay? Now, some of you guys had sine. Some of you guys had cosines. You had to be careful if you have sine. Derivative of what is sine x? Negative cosine x. Yes. You guys notice that's what sucks about integration and derivation is it's kind of like when you first learn how to drive stick. I think I've used this before. You're going in reverse now. You gotta click into the right thing. Yes.
The last portion, you wanted us to compare our answers.
Yes.
You want us to say if it was a linear or a
You could. I didn't really say you had to.
Okay, so
You could say it's close. It's off by this much, right? Should they have been close? Sort of. You only use 4 rectangles, so we'll see. I think a couple of them were closer than a couple others, just depending. But there ain't no, if your rectangle said 7 and your part, the last thing said 20, something went wrong. Okay. Maybe. If you ever run out of time, just say something like, I know these should be closer. I can't see why I ran out of time. Right? You can see what I'm saying? You might actually save a few points if you do that. Anything from homework or anything? Are you guys doing the homework? Is it happening? Okay, you sure to give it to me? Okay, what I want to do today, I want to do something a little different. Oh, we have to finish up USUP. Does anybody need this handout from before? Because on the other side, I had a whole thing about USUP. See if I can keep one for myself. That'd be awesome. This one's mine. All right, everybody else good? Okay. So if you were not here last time, what's up, Bailey? Uh-oh, but you got one from me before, right? You don't just not have one.
No, I don't think
He
I have.
wasn't here.
Oh, shit. Huh?
He wasn't here.
Oh, okay. Sorry, Bailey. I'll have to give you one later.
That's fine.
Okay. So I go over a few examples. We actually discussed why USUB kind of makes sense before. I don't want to, but let's try this. If I had this, if I had this, and I was trying to figure out what big ass F is, what's missing here?
Constant.
No, more than that.
The
If, now real quick, guys, stay with me. Big ass F has to have, the inside cannot change. The inside cannot change. When I do derivatives, the inside gets its own term separate to have its derivative done, correct?
Okay.
So the inside does not change, and I know this would have to be an eighth power, yes? If I'm doing this backwards, is everybody with me? I could write that, I know that's gotta be a part of the answer. But if I take this guy's derivative, what am I gonna get here?
you,
I would have chain rule happen, yes? I would have the 8 come down, and then what would I get from the inside?
3x squared.
3x squared. So at the very least, I
Yeah, but
really want you guys to be, but you're not gonna have to do this kind of problem. You're not gonna have to do this kind of problem. You're not gonna have to do this kind of problem. So this is a little weird. What I'm doing right now is weird. I will say that directly to you. It's weird to try to figure out what would have to be there. I'm trying to get you used to, why does something have to be there in order for this to work? Well, because I know the answer has to have this. And this, if I take its derivative, would have shit x squared in front of it, yes? So I at least need to have this there already. I at least need to have this there already. And then this guy could go backwards. Do I have the chain rule piece that would come out from here? I have it, except for what? What am I missing? A constant. I don't give a shit about that. I don't give a shit about that. That's good for you, Jeff. Little mister already did this. I'm sorry, I just want you guys to see constants we can balance. We can make constants show up. We like that with the magic people, yes? If I'm missing a variable piece, I'm screwed. It ain't gonna work the way I'm trying to make it work if I'm missing a variable piece. All right. So, does everybody kind of see when the inside gets more complicated, I need more stuff to be there already? So, for example, I could do the antiderivative of this, Jeff. Can you even write it? Yeah, let's find out. I could do the antiderivative of this. Yes? Because since this is a derivative, I know that chain rule would happen and I have to have something x squared. But I cannot do the derivative of this. That actually is impossible to do by hand. I could get a pretty damn good estimate by hand though. But it would be really gross. Calc 2, you learn a method to get an approximation for a definite interval. Okay, so let me show you. Let's kind of review U sub real quick. So if I look at this first student, let's say I want to do this integral. Can somebody remind me? There's two answers I'll accept. And there's a lot of different ways to say the two answers. What the hell does this want? What does that want? What does that represent? Good, all right, so it wants an antiderivative. And what is that function actually tied to? What does it represent? What is area? So if I gave myself some limits, it would tell me the area under the function between those two numbers, yes? So this gives me an area function that happens to be the antiderivative, which is so cool. Thank the gods. So I don't have to do all that sum of I squared weird shit from section 5.2. Yes? Maybe some of you guys are like, maybe he won't notice I don't turn that in. No, you do it the best you can. Do it. So, can somebody help me with the first step? What is it about this that tells me U sub will work? What would you let U equal? X cubed plus 8, right? 90-something% of the time, works every time. No, it's gonna be the inside function, the function that's stuck, the function that would be changing. I've shown you an example already. It was natural log of x over x, where it wasn't the function that was stuck. So 100% of the time, 100% of the time, you let U equal the function whose derivative is in there also. 90% of the time, the U will be the thing that's stuck. You all agree the x cubed plus 8 is stuck inside of sign?
Yes.
Or little g. Can't move around the world. Jeff, what have you done? There it is. If I let U equal x cubed plus 8, what's du?
3x squared.
3x squared, dx.
Dx.
Very, 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 very important. You don't forget that guy. Dear God, trying to get you ready in case you need to take out 2. And if you don't need to take out 2, you still need the damn thing. Okay. So what am I? Can I find U in there? Yes. There you are, right there. Can I find 3x squared dx currently in there? Can I? You can? I can't. Joanne's all like, I'm better than you, man. What am I missing? I can't find. I can find x squared dx. Do you guys see that? It's all multiplication. Yeah. I can reorder that shit however I want to. Commutative law. X squared dx is right there. What am I missing?
Dx.
A 3. I've got dx.
Oh, me
Yes?
too.
I'm missing a 3. Is everybody with me? As long as the thing that you're missing is just a number, you're golden. If you're missing more than just a number, you're screwed. In terms of the approach you're trying to take. Maybe it integrates a different way. Maybe it's not integral. Okay, I want you guys with me. So what do we do to help this along? How do I get a 3 to show up?
Solve for dx.
No, screw that shit. All right. There's nothing I could do. I'm gonna have to speak directly to this because everybody in the universe does this silly shit. I'm really sorry. I have very strong opinions. I don't know if you've noticed, and I'm really sorry. I know personally that if you solve for dx, you will make mistakes. Mistakes that you would not make the other way. Additionally, the idea of balancing shit happens often enough in mathematics as you go further that this is a really great place to get some practice. So what do I mean by balancing shit? Why can't I find 3x squared dx? Because I'm missing a 3. If I just write a 3 in there, that's not legal. I've done something illegal. How do I balance that?
Put a 3 on.
Put a 1/3 out front, so overall what I just do? I multiply by 1, yes? You guys see that? I multiply by 3 over 3. I can do that wherever the hell I want to, yes?
On the test, do you want us to put a 3 in there and then write the fraction on the outside, or can you just put the fraction on the inside?
Oh, you mean like, okay, I'm gonna say this, to save yourself from making mistakes, you should show yourself this step. It will also help me grade in case you make a mistake. If I don't see this, I don't see where the mistake happened. Does that already make sense? I need to see this happen. Can I rewrite this now in terms of u? Yes. What's 3x squared dx? Yes. So 3x squared dx is du. And what's this become? No? Sine of u. Yes? Can you stop for a minute, you guys? Let me know. Any questions? This is huge. This is the most common adjustment we have to make for an integral. It's not the only one. You'll learn more of those in Calc 2. This is the most fundamental adjustment we have to make an integral work. Is this u sub. Or at least make an integral easier to work with. That's a better way to say it. I don't know what the shit x squared sine of x cubed plus, I don't know what that guy's antiderivative is. But if I do this, what's the antiderivative of sine u? Is everybody honestly cool with the fact that this is equal to that? All right. If I replace x cubed plus 8 with u, is that the same as this? If u is x, and is u x cubed plus 8? Yeah, that's what the hell I called it. By the way, what is x cubed plus 8? What is it? Does anyone know? Good! I don't have a clue what this shit it is. So I could call it u if I wanted to. What do we do in algebra when there's something I don't know?
Just
I call it x. If x is taken, I use a different letter. So do you know what x cubed plus 8 is? No, so I'm going to call it u. I am as allowed to do that as whoever was who put this stupid thing together to say x cubed plus 8. Because I don't know what this shit x is. I need you with me on this. I showed you an example of how this u sub idea helps with factoring. We just momentarily replace some ugly thing with a much more compact thing, and it's easier to work with. You guys remember that? You could do another example if you want me to after this, but okay. If u is x cubed plus 8, then its derivative is 3x squared dx. So if u is x cubed plus 8, sine of x cubed plus 8 becomes sine of u. 3x squared dx becomes du, because that's what the derivative of u is. Okay, I like it. So what gets everything in motion is what you decide to make u equal. And everything comes off of that, because everybody's got to adjust to that fact. Do you all agree that this number on the outside, this thing on the outside, is the derivative of that thing on the inside? The shit on the outside is the derivative of the shit on the inside. What's inside here? U. And what's this derivative? Du. The shit on the outside is still the derivative of the stuff on the inside, yes? Those integrals represent the exact same thing. The second one is just written easier to look at. What is the integral of sine of u du? Yes? So this would be 1/3 negative cosine u, just to write it weird for a second, plus c, and then how do I finish this off? So this would be negative 1/3 cosine of, I didn't start with u's, I better not end with u's.
3x to the third plus 8.
Done. The derivative of cosine is negative sine, so the negative cancels. Derivative inside is 3x squared. This kills the 3, and it puts an x squared. Bam, that's where I started. Yes? You can very quickly check the answer. It's much easier to differentiate than it is to integrate, so you can pretty quickly check your answer. Can you guys go ahead, just take a minute, can you start with this and take its derivative? Everybody, write this down, take its derivative, do it. I think this will help. Start with negative 1/3 cosine x equals A, take its derivative, right? The plus c would go to 0, who cares? I'm gonna do this like really fully out. What really sucks is, you know, when you go from derivative to integration, that's where you're gonna hear the gears grinding. What's the derivative of cosine stuff? Negative sine stuff. Then, bless you, I have to do what?
The derivative of the inside.
Yes. The negatives do what? Cancel. The 1/3 and the 3. Cancel, yes. Isn't this what we had to start with? X squared times sine? Isn't that what we had to start with? Isn't that the beginning of the problem? Do you guys see why the x squared had to be there? Because it is what came out of chain rule. If the x squared was not there, we could not do this. This is beyond us. This is actually beyond everybody, to be honest. The best you can do is get a numerical approximation for a definite interval. We're just human. Yes.
To the du from back to the.
Sorry?
What happens to du?
Do you hear?
Yeah.
Oh,
Yeah, the derivative.
again. The du is related to the width from doing the rectangles. We go through all of that. We go through the limit, the infinite limit, blah, blah, blah. And what we end up with, practically nuts and bolts, is this is one symbol. This is one symbol. What do I mean by that? If somebody said, somebody's done this in the past, they say square root of 9 equals square root of 3. We say that again. They said square root of 9 equals square root of 3. What would you tell them? Is the square root of 9 equal to the square root of 3? What's still there that shouldn't be? Square root did its job. Why would it still be there? So what is the antiderivative? This is one function, one thing. It's the first time we've ever seen a function that's bookends. But this together says what's the integral with respect to u of this. That's why that's needed, and that's why that's needed. And the antiderivative of sine u with respect to u is negative cosine. So of course, all the elements of the functional notation that went into telling me to do that are gone. They've done their job. Okay, I like it. There's a deeper discussion we get into. I'm not going to right now, but it's enough for a nuts and bolts approach. Okay. How you feeling so far? Okay. Let's see. Let's look at this directly here. Number 3, I think I already did with you, because that was the classic example of letting you equal something that's not stuck somewhere. Pretty sure we did number 3 together at some point earlier. If you forgot, we could do it again. What did I say I was going to do, Troy? Earlier? You said you wanted to see it? I forget what it was. Oh, that's right. Before I get too far. Do you guys remember how to factor this, for example? Little dude, big dude, yes? Isn't this x times x times x? So it's x minus, so 1x minus, this is 2 times 2 times 2, 1, 2. Little tiny dude, you can only take one of each. So what goes here is the other 2 x's. What goes here is the other 2 2's. And what goes in the middle is the product of those, yes? One of each, two of each product in the middle. That's the closest outcome to making a song about that, blah, blah, blah. Okay. Cubes, we've talked about them before. They're going to show up because you got that kind of instructor. Sorry. So what if I had to factor this? You ready? You guys ready?
Give it a letter.
What do you think if I said factor? If I said factor this, people are crazy. They'll write this 3 times and they'll start multiplying it out. I'm like, holy shit. Is there a GCF?
No.
Hell no. Is it a difference of cubes? Is it a difference
Oh, yes.
of cubes? Very much, blatantly. You can't miss it, it's in your face. There you go, cube minus cube. Yes, you guys with me? It looks disgusting as shit, you guys agree? Why'd you put it there, Jeff? Because I'm evil. If I call this u, why can I do that? Well, why could the dude that used t do what he did? Because that's how algebra works. So I'm gonna call all this shit u, because none of us know what it is. I'm gonna call all this shit v. If I do that, what's this look like now? If I do that, what's this look like? What's being cubed? U. And here. Look at that shit. Do you guys see how if u and v are those things, this is the same as that? Do you guys see that? I need you to, do you guys see that? We saw this was a difference of cubes. We can see that it is. It's just got so much shit going on, I can't really see what to do. So if I just replace the shit for a minute, look what I've done. I have found the form it's in. Because for factoring, what's important for the first step? What form is it in? For integrating, what's important? What form is it in? Is it a sine? Then the integral is negative cosine, right? I mean, I need to know what it fundamentally is. So I'm trying to like take all the excess detail bullshit, put it on the side, and let me just see what it really is. Can you factor u cubed minus v cubed? What goes in the little dude?
U minus
U minus d. So one u there, so the other,
U squared.
and one v there, so the other.
V squared.
And the middle term, opposite sign, product. Now, is this the right answer? Never. In a billion years is that the right answer. Is the form of the answer, what's the only mistake?
You need to put the
I need to put the details back in. Where does this go? Wherever I see
U.
u. And this goes wherever I see.
V.
So I would just replace every u with this, and every v with that. I'm not going to because I don't care.
What's this rule again, or is this just back to?
Do it again.
Is this just difference of cube stuff? It's not really a rule to name.
Well, it's the use of substitution. And depending on who you took your factoring with, I very often show this to my students when I teach them factoring, this method. Especially if they're in pre-calculus, because then in calculus, it's on their minds. And they're like, oh, use sub, we've done this before. So this is just a place where substituting for excess shit makes things much easier to work with in the middle. You start with A's and T's, you better end with A's and T's, not freaking U's and V's. You guys, does that make the idea make more sense? That I'm allowed to do that. In the middle, I can make things look better for myself and then plug the excess shit back in at the end. Maybe. That's all I'm doing with integration. Okay, so come back here. Number one is a classic problem. What is the most likely candidate to make u? For 2 reasons. What would I let u equal in number 1? Cotangent. 2 reasons. Number 1 is because it's
The reciprocal.
Right.
inside something. And number 2, because what's the derivative of cotangent? Negative cosecant squared. Constants I don't give a shit about. So the derivative of cotangent is basically cosecant squared. Do I see cosecant squared? Yes, so there's a function whose derivative is in there that tells me u sub will work. Stop for a minute. Okay. So then u equals cotangent x. So what's du?
Negative.
Negative, cosecant squared x. Remember all the cos shit is negative when you take a derivative.
Dx.
So what am I missing? I'm missing two things. Well, I'm sorry.
Three.
I'm missing one thing and I got one extra thing I don't want. What do I not want that's in there?
3.
I don't want the dumb 3, yes?
So 1/3.
So by itself, I know I'm missing something. What can I do for that 3? I don't want him in there.
Move him on the other
I
side.
just put it. No. The 3's there. I don't want him there. You guys see what I mean when I say I don't want that 3 there? Why don't I? Can somebody tell me exactly why I don't want that 3 there?
Because he just goes, he's nothing.
Because does du need him?
No.
He's extra. Yes?
By himself, he would be. He would disappear.
So I'm just gonna take him out. What's the only thing you're allowed to put into and take out of an integral?
Constant.
It's a constant. Same thing, because an integral is just a sum. What can I take out of a sum? Anything that's in every element of the sum. Well, there's a 3 in every element. I can take it out. Why can't I take an x out? Anything related to x? Because x is changing. It's not the same in every term. Maybe. I really want you to get that. Because it's so easy to take an x out of the way, because you're like, I don't want that x, let me take it out. No, you've totally changed the problem now. So if I take the 3 out, what do I actually need in place of the 3? What do I need there? A negative. All right, that's easy enough. So if I take a 3 out, and I put, what's the only way I can put a negative in here? I'm gonna write this like this. How can I just put a negative here?
Distributed.
What do you mean by that? If I put a negative here, I better,
Every term on the inside.
no. I did put it on every
Oh,
term on the
change.
inside. There's only one term on the inside.
That's why.
Yeah, there, I gotta balance it, yes? I've gotta balance it. Whatever I multiply or divide the inside by, I've gotta balance that on the outside. Did I just change the problem? Did I change it? Did I fundamentally change it? No. I made it look different, right? So on one level you go us, ooh, look at us, we're amazing. But what can I see now inside that I need to see?
Your U and your D.
I can see my du. My du is negative cosecant squared x dx. Can everybody, that's your du, yes? I can replace all that shit with du. Because if u is cotangent x, all that shit is du. And then what do I put here? Me.
U.
So this will be negative 3 integral. All of this here is du. And this is u. So I'm going to try one more time. This integral, the way it's written right here, is a function inside of a square root whose derivative is outside. Does everybody see that? This integral is a function inside of a square root whose derivative is outside. They are the same stupid integral. This is just much easier for us to look at. So are there people that could do this without doing u sub? Yeah. Am I one of those people? Sometimes. But I still do this shit. I want to look at that much more than I want to look at that. Yes? I'm just a poor little human. I make mistakes, man. So how do I integrate u to the 1/2? What's the power become? Always start with the power, because it's... What's it?
Negative.
Nope, not taking the derivative. You're integrating.
1.
Add 1, right? So 1 plus 2 is 3 over 2. So what do I put out front? 2/3. And then the last step is, well, I can kill these. And then U was cotangent. This, sorry.
Why did you put the negative on the outside again? Just so they would match.
Because I need a negative on the inside to find du. So I need to put a negative on the outside, so overall I just did nothing. So if I start with 7 and I multiply it by a negative, and then I multiply that by a negative, I still have 7. Yeah. Yes?
How does the antiderivative of x to the n work?
The power goes up by 1, and then you divide by the new power. Just the same as derivatives are the opposite. You multiply by the old power, and then the power goes down by 1. That's how derivatives work. So integration is the opposite of differentiation. They are exactly the opposite operation. Does that make sense? So I always, when I'm about to integrate something, especially when it's got a freaky fraction, find the new power first, put the reciprocal in front, because I'm dividing by it, so that I multiply by its reciprocal. That makes it a nice, quick little nuts and bolts thing to do. Alright. Do you guys see number 2 has gross fractional powers, but it's basically the same thing as the sine one we did earlier?
Mhm.
Do you guys see, like, the inside is x to the 7/5 minus 4? What's the derivative of that? What's the derivative of x to the 7/5? You can do it. What's the derivative of x to the 7/5? The power,
7x
the power comes down, and then the power goes
down 1.
down by 1. Good. Right, and the minus 4 is just goes to 0. Yes? You guys okay? You guys start to see now, this is one of the most kind of insidious things about integration. When you're doing U sub, in the middle of an integration problem, you have to differentiate. And that again is changing gears. One's going backward, the other one's going forward. I can't do anything for you to make that simpler. I'm sorry, it's just the way it is. It's just what's needed to do this. So you have to get used to that. Really focus on what the shit am I doing right now? Which way am I going? Do you guys see how that du is there? Isn't what is this? X to the 2/5, and all I'm missing then would be well, let's do this, Jeff. You've already basically done it.
This one.
Need more room though. Okay, so let me write this a little bit better. So what am I going to put in here? U. Can I see du yet?
Yeah,
What am I missing?
that x to 7/5.
No, I'm missing
No,
7/5,
7/5.
right? So if I just put a 7/5 here, what do I have to put on the outside? So overall I did nothing. You can do it. 5/7, good. If I do that, I just multiply by 1. Yes? Does everybody honestly see that? That's all that is. If you give me any number in the universe and I multiply it by 7/5 and then I multiply it by 5/7, it's the same stupid number. Because this is freaking 1, yes? What I've done though is I've made something I need show up inside and I balanced it on the outside. I made it look different. Now I can match what my du needs. I don't know why I left all this room here. That makes no sense, Jeff. This is du. And then I got my 5/7 here. And then I've got this space left intentionally blank. Do you guys see that it becomes the same problem as before, right? Now let me ask you, if you guys had a very visceral reaction to that, where is it not making sense? I've got a function that's on the inside of another one. If I'm not sure, I try that first. Let u equal the thing that's stuck. Then you do du, and you see if the x piece is there. That's what tells you u sub will work. If the x piece is not there, you gotta try something else. That'll become a lot more important when you get to Calc 2, because then you'll know all these other things that'll work when u sub doesn't, so you have to know when u sub doesn't work. Right now, it's gonna be basically u sub or just straight up integration, so you know it's gonna work more than likely. I mean, just to finish this up, the integral is sine, negative cosine, and u was x to the 7/5 minus 4, so there you go. Integral sine u is negative cosine u, you have the 5/7 there, and u was x to the 7/5 minus 4, bam. Now, I do have a little group sheet I want you to work on here in a minute, but just suffer with me here a bit more.
This one's a little bit.
I want to do number 4 because it showcases the flexibility of u sub. And you don't get to see that too often. Not enough of us 180 teachers really try to put this in here. If you let, oh, that's right, this is not as good as I wanted it to be. You'll be okay. Strike what I just said. This is just a straight up u sub. I was excited for it.
It's number 3, that's,
Number 4.
okay.
Sorry, we are, yeah, number 3 we did before you even got the sheet. What do you guys think you should let u equal here?
You're gonna have to factor the bottom, right?
Yeah, the x squared plus 6x, 2 reasons. It's the part that's stuck somewhere. And the derivative of something squared is something to the first power, and that's exactly what's on the top, yes? Okay, man, this is a lot more boring than I thought it would be. What is that guy's derivative? So I need you to realize, you could let u equal something, get du, and realize that was not the way to go. Not the end of the world. Who gives a shit? That's part of the process. Is sometimes picking u wrong, and then you just pick something else. You guys see what I'm saying? Okay. So I picked a u because it's on the bottom. What's du? Now we're just checking to see if this might even work.
2x plus 6.
Who do what?
2x plus 6.
2x plus 6. dx.
Yeah.
Is that what's in there? Is it off by a constant? A constant multiplier, yes, not off by an addition of a constant. Is there something I can multiply this by that would make it become this?
2.
Let me say that again. Is there a number I can multiply or divide the inside by to make it become this?
Yeah.
Yes. Then I do the same thing we've done before. We try to take over the world. We also just, if I double the top, that would make du show up, yes?
Yeah.
Does everybody see that? If I double the top, du is in there. And I need that in there or else I can't make everything in terms of u, I can't do the next step. Well, if I double the top, I gotta make it legal somehow. I'm not just allowed to go, I don't like your problem, Jeff. Let me change it. Even though a lot of you guys do. Appreciate it. I don't like the way you wrote that problem, so I changed a little bit. I want somebody to write that, that'd be funny. If I double this, I better at the same time do what?
Cut it in half.
Put a 1/2 out front. So I'm balancing what I'm doing, yes? Okay. Doing the Indiana Jones thing, but we're doing it better. No boulder's gonna come after us. We're gonna just waltz right out. And then we'll start running because people wanna get us done. We'll be right. So if I double the top, I better cut the whole thing in half. So overall, we just did nothing. Go team. Now in this specific integral, what do I have to be careful about when I'm about to transfer to u?
That it's between 1 and 3.
Yeah, what's between 1 and 3? What's going from 1 to 3?
So D.
X is going from 1 to 3 because it says dx. That's how X is changing. I'm about to make everything in terms of U. I need those numbers to tell me what the hell U is doing. What the hell is U doing? So when, so everything we do for USUP is trying to make everything related to X become related to U. No X shit can be left over. If any X shit was left over, I did something wrong. I can't move forward. So let's see, before we do the numbers here, how does this look now? 2x plus 6 dx is what?
Du.
Du.
Divided by U.
And what was x squared plus 6x?
U.
U. Does everybody see that? X squared plus 6x is U, it's on the bottom. 2x plus 3 dx is du. If x is 1, what's u? If x is 1, what's u? No, if x is 1, what's u?
7.
7. 1 plus 6. Yes? If x is 3, what's u? If x is 3, what's u? 27. So as x goes from 1 to 3, u goes from 7 to 27. And then what's the integral of 1 over u? ln of absolute value u, but everything's positive, so I can do this. And I want to evaluate that between 7 and 27. So I get this kind of gross answer, but too bad.
What happened to our 1/2?
Where did I leave them out?
Yeah.
Oh, from the very beginning. Thank you. 1/2, 1/2, 1/2. So when it's a definite integral, you don't have to bring the x back as long as you change these numbers to tell you what u is doing. This here, of course, means evaluate this from 27 to 7 back. Okay. What was I about to say? Oh yeah. Guys. What's that guy's area? Oh, what's up, Jason? Just tell me. It's not a big deal. There. You write that a little better. You could use property logs, put those logs together. I don't care. Still the same thing. Oh, that should be a 7 there.
I was wondering why there was 2.
Yes.
Could you explain again, the 27 to 7 part again, how that changes?
27, you mean here?
Yeah.
Why these numbers become 7 and 27?
Yeah.
Okay,
Plug in.
here we go. So you know that these numbers tell you what x is doing. We have chosen the relationship between u and x right there. So when x is 1, u is 1 squared plus 6 times 1, u is 7. So if x starts at 1, u starts at 7. If x ends at 3, u ends at 9 plus 18, 27. That's it. Yeah. So this, doesn't x go from 0 to 4? What's the area? 20, that's crazy. What if I came in and I smoosh, right? What's gonna happen if I smoosh it and it can't compress? It's like, I'm gonna smoosh it, what's gonna happen on this side? It's gonna blow out that way, yes? You guys with me? So if I smoosh it, come back here. Maybe this is what x is doing. If I smoosh it, smoosh. it might become 0 to 10, but only go up to 2 now. I need you guys, isn't the area here 20? If I smush it, then my U, my I smooshed it, I sat on the damn thing, so that's for U, it still has an area of 10, but now it's going from 0 to 10 instead of from 0 to 4. So when we do a U sub, we are literally reorganizing the area I'm looking at. So here, let me try this. Has everybody kind of got that idea? Does that make physical sense? We've done stuff like that before. We've smooshed things on purpose and by accident. Still the same amount of stuff, it's just smooshed. Here, let me show you this. Doing this live, let's see how it goes. There's one little thing we always forget to talk about. There is a problem in the homework I signed that kind of goes over this. It doesn't say smoosh, unfortunately, that would have been funny. Come to everybody's favorite thing. What was the original? Oh God. What was it? X was 3. Okay. Check. You can do it, buddy. X plus 3 divided by, what was it? X squared plus 6x. Yes. And then if I compare that to, where'd it go? 1 over U. 1 over x in this case. It's going to be a little bit weird. It's going to be okay. So if I look at the area from 1 to 3, under the red line, versus the area from 7, this is a bad example, to 27. It's a horrible example. We'll be all right. So the area from 1 to 3 under the red line is equivalent to the area from 7 to 27 under the blue line. So I just smushed the shit out of this thing. When I smooshed it, it tried to escape. It got over here, and it got very smushed. You guys, not the best example of where I'm trying, but I started with this thing, this area, and then I smooshed it, and it moved over a bit, but it's still the same area. That's the idea. So when we are transforming from x to u, the shape of the new function has the same area as the shape of the old one. I did forget though, was there like a multiplier? This is just a 1/2. I forgot my 1/2 again. Good job, Joe. We'll be all right. There. Doesn't really change anything visually, but we'll be okay. Does that make sense? I'm literally finding the area, and it happens to be a function with this funky ass side, but we can reorganize areas. I can take a circle and chop it up and make a rectangle out of it. It's still got the same area as it did before. That is what U sub is doing computationally. Okay, let me let that go. There is one problem in the homework that kind of addresses this idea. I'll let you guys come upon it. Okay. I do want to do, let's see. Let me do this. I'm going to do one example of a U sub problem that's got a little bit of flexibility to it. Let me see if I can make one up. What about? Yes. Okay. By the way, real quick, let me show you a little motivation. If only my problem had been this instead, what would you guys do first? If only the problem would have been this instead of this. This is my problem. If only it would have been this, why is that so much better? What can I do here?
X over
X over X is 1 plus 2 over X, that's an easy integral. We're done in 2 steps. You guys see that? If the bottom is one term, that kicks so much ass. Because then I can just break it up and make a bunch of little problems out of it. Can I do that here? Dear God, no. You can't do x over x plus x over 2. That's so much bullshit. So much bull. That's really low level shit. Do not do that. So what the hell? You're right. This is a weird application of the U-sub, but I love it. I just want to show you there is creativity with the U-sub stuff. You could try some stuff out. I'm going to let u equal x plus 2. That makes some sense. That makes sense in a couple different ways. X plus 2 is the part that's stuck. Also, what did I just say? Why was the second dude so much better? Because how many terms is on the bottom? So if I let u equal x plus 2, the bottom will end up with just one term, u. But let's see where this takes us. This takes us to very nifty places. See if anybody agrees. What's du?
U is 1
1 what?
plus or dx.
Yes, du is dx. That doesn't seem good. Do you guys see why that doesn't seem good? Did I cover all my x's that are in there? If I take dx, replace it with du, take x plus 2, replace it with u, isn't there an x still on the top? Does everybody see that? So what is the main goal of u sub? Take everything related to x, replace it with stuff related to u. I can't have any x shit left over or I'm screwed. So way to go, Jeff. So look what I can do. Look what I can do. U equals x plus 2. So what's x? If u is x plus 2, what's x? X is u minus 2. So what is x? What did we just say? What's x? U minus 2. What's x plus 2?
U.
U. And what's dx?
Du.
Du. And now what can I do? I can do the shit we wanted to.
Get rid of
Look.
the
U over u is
1.
1.
2.
What's the integral of 1 du? You can do it? You can do it?
1. Oh, no.
You can do it? What's the integral of 1? No, that's the derivative of 1. What's the integral of 1? That's the antiderivative of 1.
U. Oh, x.
U.
Oh, U.
Okay, so this guy is here. He's part of the symbol that tells you what your variable is. And of course, if I just take the 2 aside, what's the integral of 1 over u?
L.
ln of u. And what was u?
2. X plus 2.
X plus 2.
2 ln x plus 2.
Jeff. Done. Not straightforward, but I knew that from the beginning because the problem wasn't actually straightforward. The bottom was more than one term. I should expect it to be a little freaky. All right, you guys start to see. That is the major thing that students aren't shown that's just so quick to show. You are allowed to solve for x in your definition of u where it makes sense. And it makes sense when you have like an extra x somewhere, like, well, I could just solve the damn thing. Do you guys get that okay? That's nice to know. Am I saying it's going to happen all over the place? No. Am I saying that could come in handy sometimes? Hell yeah. Alright. I think, any questions on that? Yes. Do it again, sorry?
Sorry, I got here a bit late, so should I could borrow a copy of the quiz and just get started, or should I wait to?
You could have a copy for yourself, but whatever you make on the next test will take the place of the missing quiz grade.
On the next test?
Whatever you make on the next test will take the here is it.
Oh, okay.
You can have this for yourself.
Oh,
Okay. But it won't be a 0. It'll be whatever you make on the test. So, if there's no more questions on U-sub at the moment, I need to start to transition us into chapter 6. And for that, I've got a little handout where I will thankfully shut the hell up for a bit. I talk so damn much. I think though, let's go ahead and take a break so we can have a nice fresh thing when we get back. So come back at 15 after. We'll do this handout. We'll start getting chapter 6. Don't forget when I do this, you guys can ask me questions. If I'm in the room, feel free to ask questions. you do the second one. So we are gonna have to do this step, the number 1A. That is gonna be a part of many of the problems. So we had to get over and remember how the hell to find out where two lines or two curves intersect. You literally just set them equal to each other. You want this output to equal that output. So then you start to simplify, start to solve it. Never divide by a variable expression. You have a power other than 1 on your x, so you get everything on one side, get it equal to 0, and then factor. So I get 0, -1, and 1. So what points do they intersect at is 0, 1, -1, 0, and 1, 2. So if I plot those 3 points, I've plotted 3 points that both functions go through. I've already kind of laid the sort of some of the structure for both. Now the straight line is nice. Can't beat a freaking straight line. Straight line. Straight line. That's pretty good for me. Make that a little bigger. There you go. Straight line. Straight line. And then you just have to know the shape of a cube. It's gonna curve, it's gonna have concave down, and it's gonna have concave up. Right? So it's gonna have to go like this. And if you want to be really sure, when you plug if you plug a -0.5 in, you'll get -1/2 cubed is -1/8 plus 1 is almost 1. So that would be almost 1. So I know this is gonna be up here. Do you guys see that? If I know where two things meet, if I pick a number in the middle, I can see which one's on top. The idea of which function is on top is huge in this next chapter. I want to know which function's on top. So back here, the cube is on top, and over here, the cube is on the bottom. So that's roughly what I saw from everybody who got to the point where you could graph this thing. Okay, how are we doing so far? Now,
How can you tell
for which part?
for what's on top and what's on the
Oh,
bottom?
like I said, if I know where they meet, if I know 2 points where they meet, I just pick a point in the middle. When I plug it in, I got almost 1 for cube, and -1/2 plus 1 is 1/2. So this is almost 1 and this is 1/2, so this is up top. Okay. Now on this specific problem, you really didn't have to do that because we know the shape of a cube. So it should have been easy to tell the cube should be up here over and then down there. But you can always pick a point in the between two where they meet, and you can tell which one's on top, which one's got the bigger output. Yeah. So what does this represent? Area where?
Under that function.
Between what and what? Between the line
X-axis.
and the x-axis, kick-ass. You guys kind of with me. So that would be, let me see if I could do this carefully. That would basically be this area here, yes? All of this. What would this be? You're not gonna believe this, but same thing, just under the freaking cubish dude, yes? So that would be this area here. So if I subtract those two areas, what do I get visually? If I subtract those two areas, the one that's below that and the one that's below this, if I subtract those two, what am I left with? The area where? In between them, the little banana, the blue banana area, yes? Do you guys see that? Weirdly enough, there's gonna be more banana-shaped things in this next section than you're going to be used to, because they're going to have a lot of overlapping, and very often they end up looking a little banana-ish. Is everybody kind of with me? You guys with me? Okay, if it's a blue banana, I'm not sure if you want to eat that. So what would this represent? The area between the cube dude and the x-axis. So if I subtract the two, I'll get the area that's caught between the two functions. And then, now I notice a few people just really overthinking this. Once I start to do the integral, I could just simplify this dumb thing, yes? If I distribute the negative, the ones cancel. And then the integral's nice and easy, yes? What do I get?
1/6.
I mean, what do I get on this next step?
1/2 x squared minus 1/3 x to the 4th.
1/4, yes? Because this is x cubed. X to the 4th, yes?
Oh,
Is that okay? And then I'll get, is that all right? Okay, maybe. So raise the power, divide by new power, raise the power, divide by new power. When I plug a 1 in, I get 1/2 minus 1/4 is 1/4. And when I plug a 0 in, I get 0. So the area in this little banana section is 1/4. Little banana. Do you guys see that? So how do I find the area between two functions? What is important? Why did I, now real quick, let me make this really, really clear. Why did I put the functions in the order I did? Why did I put x plus 1 first? That is really important. Why did I put the x plus 1 function first? Why did I put x plus 1 first?
bigger.
Because it's the function that's on top, yes? You with me? Okay, so the better your rough sketch is, the easier you could tell. But even if you didn't make a sketch, you could plug 1/2 in and tell that this guy is on top because he has a bigger output there. So you would put him first, so if I do this area minus this area, of course I get the area in the banana. Little calculus banana. Maybe? So if I give you any two functions, if I gave you, the back is going to be a little, not the back, but this guy's going to be a little weird because I made y the deal. But if I just gave you two functions, and I want to know the area between those two functions, I would first figure out where they meet, and then I figure out who's on top in that hole from the between where they meet. I want to know who's on top. That's the function I put first because I want to subtract smaller from bigger. Okay. You guys notice when I do this process, I always get a physical area. This whole picture could have been underneath here, and this would have still been a physical area. It would have been positive. So when I do this type of thing, find the area between two functions, I always get a positive area. It's a physical area now. Okay. So let's look at this guy. What time we got? Okay, we got. You guys do 2A first. Oh wait. Go ahead and do 2A. Alright guys, in the interest of time, let's take a look here.
Oh, yeah, no, you're. I found a cider. I know I missed it, so.
So one of the most important things to learn from mathematics is a new problem is not a brand new way of doing things. Am I trying to solve an equation where my variables have powers that aren't one? Do any of my variables have powers that are not one? Yeah, I don't give a shit what the variables are, what I'm trying to solve for, what the powers are. If it has a power that's not one, I get everything on one side equal to 0 and try to factor it. That's what you always do. It's what we did on the last problem. Why? Because add a cube. And I got a couple things with squares on them. I'm hoping they'll cancel, but I see they won't. So I get everything on one side equal to 0. That's the only way factoring will do shit for me. Yes? Can you guys tell me right now what two numbers multiply to be 10? 2 and 5, 1 and 10, 1/8 and 5/4. Where's 8? 8 5/4. I mean, do you start to see 1/10 and 100? Those multiply to be 10. Yes? No? Screw you, Jeff? What the hell are you talking about? Do you guys kind of start to follow? I can't have it equal 10 and do shit. I have to have it equal 0. What two numbers multiply by 0? One of them has to be 0. That's the only time we know something for sure is if I have two numbers multiply by 0. If they multiply by anything else, there's an infinite number of things they could be. I don't want that. I want something definite. So, if I have a power, if these were not here, what would you do? If the y-squares were not there, what would you do? Get all your y's together and then divide, right? These dumb things are there. Can I get all my y's together into one term? No, I cannot because they are not like terms. So I can't do that shit. The minute I have a power other than 1 on any of my variables, I'm kind of screwed. The only way out is to get it equal to 0. Get everything on one side. Okay. Add y squared, subtract 6y. Now before you start trying to factor this thing, what can you do? Yeah. Now factor it. -1. -5. So then y equals 5 and 1. Okay, good, right? Yes, yes. You see how it's the same shit we did on the other side, or on the other paper? Same exact stuff. Do we factor it the same way? No, that's not what I mean. We factor it, and then we can see what makes it 0. What are my points, though? Where do 1 and 5 go? Where do I put the 1 in this point? Here, because that's what y is. When you plug a 1 in, what do you get? You get 5. And either one, yes? Either one gives you 5, yes? 1 minus 6 plus 10, and then -1 plus 6, 5. And then where do I put the 5 here? Here. That's what y is. And what's x going to be if y is 5? Yeah. 5? Yes, 5. Thank you. Kick ass. Okay. You guys see that? So what's unfortunate is you really haven't worked a lot with functions that are solved for x instead of y. They work basically the same way. It's just you gotta be careful when you put your points together, you gotta put stuff in the right place. This is still y, it should still be second. It's a coincidence this came up to be 5 too. So I know both functions go through 5, 1. Sorry about the scale here. We're gonna be okay. And 5, 5. Let me see if anybody can figure this out. By the way, do you guys, y equals x squared looks like this, yes? Looks like this? What does x equal y squared look like? There it is. YMCA. So yeah, they look like this or like this. right? Y equals x squared, y equals negative x squared. X equals y squared, x equals negative y squared, yes? So, it's gonna look like, one of them's gonna look this way and the other one's gonna look that way. The only thing I need is the vertex then. Does anyone understand what y value is gonna be where the vertex is? What's the y value have to be? Where's the mirror for a parabola? If I know these 2 points, where's the mirror? Right in the middle, yes? So this is y equals 1, this is y equals 5. What's right in the middle? What's right in the middle of 1 and 5? 3. So if I plug a 3 into each function, I'll know one vertex will be over here, one vertex will be over here, because I know one is opening left and the other one's opening right. The same thing as up and down in the other direction. So if I plug a 3, so let's see, if y is 3, here x is 9 minus 18, negative 9 plus 10 is 1. If I plug a 3 in here, I'll get x is 18 minus 9 is 9. So I get, you can double check me on that. I don't know if I trust myself. Yes, that looks right. So x is 1, 3. 1, 3. And x is 9, and then the other one is 9, 3. So 9, 3. So I got one parabola looking like this, and the other one looking like this. So I get a little football that maybe the Patriots have messed with. No deflate gate people. Okay. So I want to find the area between those. Top and bottom are weird here, but the idea of top is the one that is bigger, has the bigger output. Which parabola? I should have kept track of which one was which. This one is here. This one is here. Which parabola has the larger outputs between these 2 points? When I say output, what variable am I referencing in this problem? X, right? So what variable goes more to the right? Which parabola goes more to the right? This guy. He's the one, so if I rotate this, he's the one that's on top. So if I do an integral right now of just this, I'm going to get the area between that curve and the y-axis. So if I put y's instead of x's, my picture just turns. Yes? So if I have a normal function, dx would be the area between the function and the x-axis. If I just rotate that whole idea, the integral of this dy between here is going to be the area from the y-axis up to the curve. So if I just subtract from that, this dude, I'll end up with the area of the frickin' football. So, first off, it's dy, yes? What is y going from to? What's the lowest y is and the highest y is? Yes, the lowest y is 1. And the highest y is 5. What's the function on top?
Negative y squared.
Yes, negative y squared plus 6y. So from that one, I'm going to subtract the other one. And then the rest of this is pretty straightforward. Damn, it's already almost there. Then you would get your like terms together, you would do the antiderivative. It's a polynomial, so nobody can cry about that. Okay. That's section 6.1, by the way. Section 6.1 is the area between two curves. 2 things. This Wednesday, we're gonna get into 6.2 and 6.3. Next Monday is when we're supposed to do 2 things. We're supposed to finish up chapter 6 and review for the test that's happening a week from this Wednesday. You guys kind of with me? So that's a little crazy. So I think whatever we get through on Wednesday is going to be what we get through. What's happening first thing Wednesday? Another quiz. Yay! It's gonna be on 5.2 and 5.3. Yes? Okay, that's enough. I gotta get over to the Sissel. I'm gonna be late. Hold on.